And here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today, eventually we're going to go on to do section 14.2. But first, I've got a couple of things to tell you and some problems to work out. So let's get right to it. The first thing I want to talk about is there is a math lab or a math center in Zoom sessions that is available to you. And the ID for that is 509-574-6827. I don't know offhand what the hours are, but you can go into your Zoom app, type in that ID, and it should take you into the Math Center if it's at a time they're open, and then they will guide you from there. All right. Next thing I want to look at is somebody emailed me and said, hey, how do you know, this goes back to section 3.7 and 4.5, how do you know when a line is dashed or a line is solid? Let's say you've got y greater than 2x plus 3. Here, because the inequality does not include equals, it would be a dashed line. Let's say, for instance, you've got y is less than or equal to 7x plus 5. Here, because it includes the equals, it would be a solid line. So if there's no equals involved, it's a dashed line. If there is equals involved, it's a solid line. Okay, and now two different people actually emailed in the exact same question, and it happened to have the exact same numbers. Not everybody has the same numbers, but this is from section 14.1, number 11, and the problem says evaluate the expression, and it's 5 factorial times the quantity 8 minus 5 factorial all over 4 factorial times 7 factorial. To me, the key to this problem is being able to reduce it down as much as possible. So initially, I'm going to take 8 minus 5, which is 3. So I get 5 factorial. Could somebody mute your microphone? We're getting kids coming through. Thanks. All righty. If you want to talk, that's fine. But otherwise, please keep them muted. Okay. 8 minus 5 is 3. So we get 5 factorial times 3 factorial over 4 factorial times 7 factorial. Well, let's see. I could take these two and reduce them down, and I could take those two and reduce them down. So for instance, 5 factorial on top, I'm going to take 7 factorial and write it as 7 times 6 times 5 factorial on the bottom. 3 factorial on top, I'm going to take 4 factorial and write it as 4 times 3 factorial on the bottom. By doing that, I'm able to reduce out the 3 factorials, that is, reduce them down to 1 over 1. They don't cancel, they don't disappear, they reduce down to 1 over 1. And the 5 factorials reduce down to 1 over 1. So now in the numerator, I have 1, and in the denominator, I have 4 times 7 times 6. So now I'll go to my calculator, and 4 times 7 times 6 is 168. Now, the problem that I think some of you had is you didn't reduce it down first. You got this huge number in the numerator and in the denominator, and then you just left it alone, or some of you just forgot that there was a 1 in the numerator. Anyway, this is how you could get to that final answer. Do any of you here have any questions about this before we go on? All righty. Then we're going to go on to section 14.2, and we're going to look at what is called, put my glasses on so I can read, arithmetic sequences. Okay, arithmetic sequences. All right. Now, an arithmetic sequence is a sequence of numbers, one right after the other, that have certain properties. And I want to talk in just about some notation and things. If you have some numbers in a sequence, well, in fact, let's take a sequence. When I teach Math 50, oftentimes my assignment to students will be, starting with problem number 1, do every other odd problem. So you'd do 1, you'd skip 3, you'd do 5, you'd skip 7, you'd do 9, you'd skip 11, you'd do what, 13, skip 15, 17, etc., etc. Okay, so this would be an arithmetic sequence, and let's take a look at it. The first term of an arithmetic sequence would be labeled A sub 1. Sub 1 meaning the first term. The second term would be A sub 2, and then A sub 3, that's a 9, and that's an A sub 4, A sub 5, etc. The general term would be A sub n. Any questions about that? All right. Let's go back and let's look again at this sequence 1, 5, 9, 13, 17, excuse me, etc. Can you see that between each pair of terms, there is a common difference? In other words, if we take a term in the sequence and subtract the previous term, so 5 minus 1, what do we get? We get 4. If we take the third term minus the second term, 9 minus 5, what do we get? We get 4. If we take the fourth term minus the third term, 13 minus 9, what do we get? 4.
4.
Right, right. So 4 is called the common difference. Okay, so you add 4, you get to the next, you add 4, you get the next, you add 4, you get the next, but the difference between a term and the next term is 4. Okay, now let's go back again and look at this sequence. Let's see, 9, 13, 17. So this term is A sub 1 because it's the first term. Okay, the second term is A sub 2, but it's also A sub 1 plus 4, isn't it? You see that?
Yeah.
Sorry?
Yes.
String on line like 30.
Okay, I think that was something for somebody else. The third term, hang on a second here. I see that I wrote something I should have said. This is A sub 2. So A sub 2 is A sub 1 plus 4, right? A sub 3 is A sub 1 plus 2 times 4, because we've got 1 plus 4 is 5, plus 4 is 9. Okay? A sub 4 would be A sub 1 plus 3 times 4. A sub 5 would be A sub 1 plus 4 times 4. Again, do you see where I'm getting that? Have I lost you? Or are you still with me? No one has a comment.
Got it.
You got it? Okay. All right. I'm going to add one more thing here. I'm going to go back here. Hang on. Come on, eraser. And instead of writing it like this, I'm going to put this is 1 times 4, which is still 4, right? Okay. Now, what I want you to notice Each of these terms is written in terms of the first term, okay? And then it has a certain number times the common difference of the terms, okay? What I want to look at is the relationship between this number and that number, 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 okay? What we get is this. A sub n, so a general term in this sequence, is equal to a sub 1 plus n minus 1 times d. Now, d is the common difference. So that's the 4. N is the subscript on the term. So n is 1 here, 2 here, 3 here, 4 here, 5 here. But how many times do we take the common difference? We multiply it by the subscript minus 1. Okay. Now, if you're not getting that, let me do this again. Let's take this formula, a sub n equals a sub 1 plus n minus 1 times d. Okay.
So where did you get the D from?
Where did I get the d from? Okay, the d was the common difference that we found. Okay, so that's the 4. Okay. You okay with that? Hello? I guess so. All right. So a sub 1 is 1. Okay. A sub 2 would be, and now I'm going to use this formula. It would be a sub 1, which is 1, plus n minus 1. What's n? N is 2. 2 minus 1 times the common difference, which is 4. So that would be 1 plus 1 times 4, which would be 5. So a sub 2 is 5. A sub 3 would be a sub 1, which is what? 1 plus n minus 1 times the common difference, which is 4. But what's n? N is 3. So a sub 3 is 3 plus 2 times 4, which is 9. So a sub 3 is 9, which is going back to here. We've got 1 and 5 and 9. And you might be saying, well, why go to all that trouble? Can't you just take a number and add 4 and get the next one and add 4 and get the next one? Yes, you could. But what if I want to know the 48th term in the sequence? A sub 48 would be a sub 1, which is 1, plus n minus 1, 48 minus 1 times 4, which is 1 plus 47 times 4, which is 1 plus, let's see, 160, 188, which is 189. So if I started out, went 1, 5, 9, 13, 17, on and on and on, the 48th term would be, what was it, 189. Are you okay with that? Do you have any questions yet?
I had a question about how you got the n minus 1 in the equation.
Okay. So let's go back here. A sub 1, we said, was 1. A sub 2 is 5, but it's also equal to a sub 1 plus 1 times 4, right? This plus 4 gives us that.
Yeah.
Okay. A sub 3 is equal to a sub 1 plus 2 times 4. Okay.
Okay.
A sub, let's see, a sub 4 is equal to a sub 1 plus 1, 2, 3 times 4.
Yeah.
But now go back and look. A sub 1, that's the first term. A sub 2, the second term. A sub 3, the third term. A sub 4, the fourth term. How many times do I multiply by the common difference? 3 of them here, 2 of them there, 1 of them there. But this 3 is 1 less than the subscript of the term. So if the subscript of the term is n minus 1 would be the number of times we'd multiply by the common difference.
Got it. Thank you.
I know it's kind of, it's too early in the morning for this, isn't it? All right.
And I got some background talking going on.
Yeah. Can't tell them to go somewhere else and talk, huh?
Not when they're working and we're in a wall-less studio.
Okay. All right. Well, I guess do the best you can. All right. So this formula, a sub n equals a sub 1 plus n minus 1 times d, is a formula that you'll be using on arithmetic sequences. This is a formula that you can have with you when you take your test, okay? Though by the time you take your test, you should have it memorized anyway, but all right. Now, I want to look at some problems where we're going to use this formula. Okay, this first problem says, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. Okay, so we want to find the first 5 terms of an arithmetic sequence and the specified term. Okay, this is what it tells us, this problem. It says the first term is 3, and the common difference is 2. And then it says, find the 10th term. Okay, so it's an arithmetic sequence.
Yeah.
We're supposed to find the first 5 terms and then the 10th term. The first term we're told is 3, and the common difference is 2. Now, here's what we're going to do. We're going to find the first 5, quick and easy way, because they're consecutive. A sub 2 is what? It's a sub 1 plus the common difference. So what's 3 plus 2?
5,
What's 5 plus 2?
7,
What's 7 plus 2?
9,
What's 9 plus 2?
11.
Okay, now we could find a sub 6, a sub 7, a sub 8, a sub 9, a sub 10 and do it this way. But what if they asked us for a sub 412? You wouldn't want to do it that way. So what I want to do now is, without just counting each one consecutively, let's find a sub 10. So a sub 10 is going to be, now what I'm doing is I'm looking at this formula, okay? It's going to be a sub 1, which is 3, okay, plus n, which is 10 in this case, minus 1 times d, which is 2. So again, this came from there, this came from there, and this came from there. Any questions yet? All right, so a sub 10 equals 3 plus 9 times 2, 10 minus 1, okay? A sub 10 equals 3 plus 18, a sub 10 equals 21. So there's the first 5 terms, and there is the 10th term of that arithmetic sequence. Any questions on that? All right, let's take a look at another problem, very similar. Same directions, we're going to use the same formula. A sub n equals a sub 1 plus the quantity n minus 1 times d. Again, we're to find the first 5 terms and then the specified term. So we're going to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. It says the first term is 8. The common difference is negative 5. Find the 25th term. Okay. Now, again, To find the first ones, I can just add the common difference for the consecutive ones. What's 8 plus -5?
Crazy
3.
or whatever.
What's 3 plus -5?
-2,
What's -2 plus -5?
-7,
What's -7 plus -5?
-12.
Okay, now, but you don't want to do that 20 more times, do you? So, a sub 25 is a sub 1, which is 8, plus n minus 1, which is 25 minus 1, times d, which is -5. So again, do you see where I'm getting all those numbers to plug into the formula?
Yeah.
A sub 25 is 8 plus 25 minus 1 is 24 times -5. A sub 25 is 8 plus, let's see, 24 times -5 would be -120. So A sub 25 is what, -112? So there's your first 5 terms and the 25th term. Any questions on that? Okay. Let's take a look at another one. It says the first 3 terms of an arithmetic sequence are shown below. Find the specified term. So again, we're dealing with an arithmetic sequence. So we're going to use a sub n equals a sub 1 plus n minus 1 times d. The first 3 terms, a sub 1 is 4, a sub 1 is 1. Let's see here. A sub 2 is 4 and a sub 3 is 7. And we are to find the 30th term. So we need to find a sub 30. All right. Now, earlier I talked about how to find the common difference. What's the common difference here?
3.
3, right. If you take any term, let's take this one, minus the previous term, you get the common difference. 4 minus 1 is 3. 7 minus 4 is 3, right? So the common difference is 3. All righty. Now, we know a sub 1. We know the common difference, and we also know n. For a sub 30, we would get a sub 1, which is 1, plus n minus 1. N in this case is 30. N is always the subscript of the number you're trying to find, minus 1 times the common difference, which is 3. Again, any questions about where I got those numbers? All right. So this would be 1 plus 29 times 3, which is 1 plus, what is that? 87, which is 88. So a sub 30 is 88. We all right with that? Any questions there? Okay. Next problem. It says, write the first 5 terms of the arithmetic sequence with the following properties. Yeah, that's what it says. Okay. So it's an arithmetic sequence. A sub n equals a sub 1 plus the quantity n minus 1 times d. We're supposed to write the first 5 terms. Okay, so a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. It says the first term is 5 and the 5th term is 29. Okay. Now, we need, for the formula, we need to know what n is. We need to know what a sub 1 is. and we need to know what D is. Let's take a look at a sub 5, okay? A sub 5 would be a sub 1, which is 5, plus n minus 1, which would be 5 minus 1 times D. Now, I know that a sub 5 is 29. We're going to get to that in a minute. But do you see that based on what I do know, I could say that a sub 5 is the first term plus n minus 1 times D. If I simplify that further, I'll get a sub 5 equals 5 plus 4D. Because 5 minus 1 is 4. 4 times D is 4D. Okay. But I also know from this information that a sub 5 equals 29. Well, if a sub 5 equals 5 plus 4D and a sub 5 equals 29, then we could say 5 plus 4D equals 29. You see how I got that equation? Two different, a sub 5 equal two different things. So those two things are equal. So now I can solve this equation to determine what D is. Subtract 5. 4D equals what? 24. Divide by 4, D equals 6. Well, now that I know that D equals 6, a sub 2 is 5 plus 6, which is 11. A sub 3 is 11 plus 6, which is 17. A sub 4 is 17 plus 6, which is 23. A sub 5 is 23 plus 6, which is 29. And there we go. But the key to this whole thing was coming up with an equation based on two different ways of writing a sub 5. Any questions on this problem before we go on to another one? All right, let's do another one similar to this. Again, it says write the first 5 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5.
So is the A right there, is that a comma or is A sub 1 on your
Right here?
equation? Yes,
You tell me, what is it?
I thought it was like a comma.
No, it's a 1. The formula is a sub 1 plus, yeah, it's always been a 1. Sorry for my
Okay.
sloppy writing, but the formula is a sub n equals a sub 1 plus n minus 1 times D. Okay, so that's a 1. All right, now it says the first term is -4 and the sixth term is -39. Okay, but they want us to come up with the first 5 terms. If we could determine what D is, all we'd have to do is just take a sub 1 plus D to get a sub 2 plus D to get a sub 3, etc. Okay. Now, I'm basically going to do the same thing I did on the previous problem. A sub 6 is a sub 1, which is -4, plus n minus 1, which is 6 minus 1 times D. Simplifying further, a sub 6 equals -4 plus 5D. But we also know that a sub 6 equals -39 because we're given that information. So we're finding a sub 6 in terms of D, and we're taking a sub 6 as it is given. So now this equals that. So our equation becomes -4 plus 5D equals -39. Solving for D, we'll add 4 to both sides of the equation. Then we'll divide both sides by 5, and D equals -7. Okay. Any question about how I found D? So if a sub 1 is -4, a sub 1 plus d, so -4 plus -7 is -11. -11 plus -7 is -18. -18 plus -7 is -25. -25 plus -7 is -32.
-32.
-32 plus -7 is -39. It checks. So we've found the first 5 terms. Again, how do we do that? We create an equation by saying the 6th term equals that, and the 6th term also equals that. Set them equal to each other and solve for D. All righty. Any questions before we go on? All right. Now, do you know what a mean is? And I don't mean like somebody's not very nice, but the mean is kind of like the middle or the average.
Average.
Yeah, or maybe, yeah, okay. So, and we could go on about that, but the next set of instructions says this: insert the given number of arithmetic means between the numbers, okay? And it says 2 arithmetic means between 2 and 11. Okay, so my first term is 2, my last term is 11, but in between 2 and 11, there are 2 other numbers, but the numbers are evenly spaced, okay? So a sub 1 is 2, then I'm going to have 2 arithmetic means, which means that 11 is a sub 4. Okay, why do I know that 11 is a sub 4? Because I've got a sub 1, then I've got 2 more arithmetic means, 2 more terms, a sub 2 and a sub 3, finally a sub 4. Okay, well, at this point, this problem is just like the last 2. I need to find the common difference. So using the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 4 equals a sub 1 plus 4 minus 1 times d. A sub 4 equals 2 plus 3d. But also a sub 4 equals 11. Therefore, 2 plus 3d equals 11. I'll pause there for you to get caught up. Again, any questions about what I'm doing here? I often question myself, what am I doing here? But that's another story. All right, so now let's see. Let's solve for d. We'll subtract 2 from both sides. 3d equals 9. Divide by 3, and d equals 3. So 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. And you might sit there and go, you know, I could have sat there and play a trial and error and figured it out eventually. You're missing the point, okay? I mean, the problems could be way harder than this, but the process would be the same that we're using here. Okay, let's see here. Let's do this one. It says, insert the given number of arithmetic means between the numbers. 4 arithmetic means between 10 and 20. So a sub 1 is 10, but then we've got 4 numbers in the middle, which means that a sub 6 is 20. Okay? So find 4 arithmetic means between 10 and 20. So using the formula, a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 6 equals a sub 1 plus 6 minus 1 times d. A sub 6 equals 10 plus 5d. But we also know that a sub 6 equals 20. So 10 plus 5d equals 20. 10 plus 5d equals 20. Subtract 10 from both sides. 5d equals 10. Divide by 5, d equals 2. 10 plus 2 is 12, plus 2 is 14, plus 2 is 16, plus 2 is 18, plus 2 is 20. That one was pretty easy. Let's do one that's not quite so nice. All righty. We good to go on?
Yes.
Okay. We are to find 3 arithmetic means between 20 and 30. So a sub 1 is 20. Then we've got 1, 2, 3 arithmetic means. So a sub 5 is 30. Okay. A sub n equals a sub 1 plus n minus 1, the quantity times d. So a sub 5 is a sub 1 plus 5 minus 1 times d. Simplifying, we get 20 plus 4d. But a sub 5 is also 30. Therefore, 20 plus 4d equals 30. 20 plus 4d equals 30. Subtract 20 from both sides. 4d equals 10. Divide by 4d equals 10 over 4, or 5 over 2. Now, I could write that as 2.5. I could write that as 2.5. Keep in mind the warning I gave you, I think on the first day. Mixed numbers don't work well in WebAssign. So, and also you don't want to round off a decimal number. So unless it's an exact decimal number, you probably should use fractions, which is what I'm going to use here. So the common difference is 5 halves. Okay. Now, a sub 2 is what? It's 20 plus 5 halves. Okay, I'm going to change that so that the whole thing is an improper fraction. Wouldn't 20 over 1 be 40 over 2? 40 over 2 plus 5 over 2 is 45 over 2. Okay. Are you okay with how I got that?
Yes.
All right. A sub 3 would be 45 over 2 plus 5 over 2. Oh, well, 45 over 2 plus 5 over 2 is what? 50 over 2, which is 25. Nice number there. Okay. A sub 4 is 25 plus 5 over 2. Let's see, 25 plus 5 over 2 would be, let's see, we'd multiply by 2 over 2, we get 50 over 2 plus 5 over 2, which is 55 over 2. 55 over 2. So now 45 over 2 does come out to 22.25, and 55 over 2, 27 point, I said 0.5. Anyway, you could write these as exact decimals and they'd be fine. But if they aren't, it won't be fine. So I would stick with fractions personally. All right, any questions on that one? Okay. One more. Insert the given number of arithmetic means between the numbers. One arithmetic mean between -4.5 and 7. So the first term is -4.5, and now here they're using decimals. There's one arithmetic mean, so then the third term is 7. Okay? Again, we're going to use a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 3 equals a sub 1 plus 3 minus 1 times d. a sub 3 equals negative 4.5 plus 2d, but a sub 3 also equals 7. So negative 4.5 plus 2d equals 7. We're going to add 4.5 to both sides. 2d equals 11.5. Divide by 2. Oops. D equals, let's see, what's 11.5 divided by 2? 11.5 divided by 2. Or could we turn that into a fraction? How would we do that? We'd multiply by 10 over 10, 115 over 20. Could we reduce that by taking out a 5? Let's see. 20 divided by 5 is 4. How many 5s are there in 115?
23.
23?
No.
Hang on here.
Is this our?
I think I did something wrong. So just a minute here. Let me go back and see if I made a mistake somewhere. Oh, I see. I'm not done. That's why. Okay. There would be, what, 23?
Yes.
Okay. Yeah, I was thinking that that was supposed to be the final answer, but no, I've got to take that and add it to this to get my a sub 2. Sorry. I was right, but I thought I was wrong. Okay, so negative 4.5 plus 23/4. What's that? Let's see. Negative 4.5 plus 23 divided by 4 is 1.25. What would that be as a fraction? Any ideas? I mean, that's a correct answer, but how could you change that into a fraction? You'd have to multiply it by 100 over 100 to get rid of the decimal. What goes into 125 and also goes into 100?
5.
Think bigger.
25.
There you go. Yeah. Oops, or 5/4. And again, either one of those answers would be correct because they're exact. But if you get some fraction like 17/11 and you write a decimal and you don't, and it just keeps going and you round it off, it's going to be wrong. Okay. I already had somebody that they took let's see, what was it? It was 5/3 and they wrote 1.6. Well, it's 1.6 repeating because it'd be 1 2/3, but you can't, rather than try to write 1.6 repeating, you want to just stick with a fraction that's reduced down as far as it can be, but don't write it as a mixed number. Anyway, I've rambled on enough. So over the weekend, you've got 14.2. On Monday, we're going to wrap up this information for the first test by taking a look at geometric sequences in 14.3. Then on Tuesday, we will review, and on Wednesday, you'll have your first test. So have a great weekend, and I will see you later.